Alright, so here we are with Chapter 3, and these are going to be your Day 3 notes. So, in our Day 1, we kind of defined a function. So I'm just going to officially give you our definition from the textbook that we tend to use. A function is a special type of relation that pairs each domain, which we're now going to kind of reiterate that a domain are the inputs, and then we're also going to say that they're the x values, with exactly one range value, or output, or y value. Alright, so the idea here is that if you have an equation, okay, if you make that a special equation, it's going to end up being a function. And so we will talk about what makes a function actually on the next slide. So what makes a function is this thing called the vertical line test. So again, up until now we've just been going with equations, yay, but now we're going to talk about equations that can be special as functions. And so what makes a function is that it has this one-to-one relationship. So, for instance, if I plug in an x into the equation of 3, I will only get one number back out. And you're saying, well, when would we ever not get one number? Well, it happens, okay? So, what happens is if you have whatever the function happens to be when you graph it, and you do this vertical line test to it, you are imagining an infinite set of vertical lines, and you're hoping that every single one of them, if they're perfectly vertical, will only ever touch the equation at one point. Okay, so this one passes the vertical line test. Okay, so if I draw one that doesn't pass the vertical line test, for example, oops, I wanted that to be green. Alright, yes, this can totally be something that you'd actually end up graphing. And so if I draw a vertical line, that passes. But right there, for instance, and even right next to it, and over here, these do not pass because they end up intersecting too many times with the equation. It can only be once. Alright, and so in that case, this one fails the vertical line test. And what does that mean? That means this one is a function, and that means this one is not a function. So again, equations up till now have just been something that you could go ahead, plug in, and plot. But now, if you plot that thing and you end up having these pieces that repeat on these vertical lines, that's a no-no, and it's not a function. Can it still be graphed? Sure. We just can't call it a function. Okay? So, all we need to do is draw infinite vertical lines. Okay, and again, we do not want the function to pass that vertical line more than once. Alright, so then we move on to a domain and a range, okay? And so this is actually what helps you determine if something is a function or not, because you're giving it, you're giving a name to where it exists. So, domain are the set of x values contained in a relation written as an inequality or a list. All right, and so what happens is if you have a list of points, you end up using these curly brackets, which I am not drawing very nicely. They're supposed to look like that. There we go. Anyway, so the idea is that if you have an independent variable, it represents the input, and it represents the x's. Okay, versus, of course, the next one, which actually represents the output, or the y values. So its official definition is the set of y values contained in a relation written as an inequality. Remember, inequalities are that less than or equal to idea, or a list, of course. Okay, so what does that mean? Well, what happens is if something ends up terminating, okay, so it ends, for instance, you're going to end up using things that have a less than, a greater than, less than or equal to, or a greater than or equal to. If you have something that's continuous, you're going to end up using things like negative infinity, yes, and infinity, okay? And if you have points, you're actually going to just start listing the values that the dots exist on. All right. So what does that mean visually? That means that if you graph something, which of course is what we did in our previous assignment, if you have an open circle at maybe -3, and then the graph continues on, and then there's this closed circle at 2, the domain are all of the x values that exist. So if we go on the x-axis, or kind of across here, you'll notice that -3 to 2 are your x's. And then, of course, -3 is not included, and 2 is included. And so how would we write that in a previous chapter? We'd have written that -3 is not included, 2 is included, and we are talking about all of the x's between. So this is a very weird way of saying it, but basically you put your lowest number here, and your highest number here, and you put your variable in between. So what does that mean for the range, which we said are the y values? So this was your domain. Well, the range, again, you try to see how high up it goes. So let's say it went up to 2 and down to -3. That means that your highest value is at 2, your lowest value is at 3, and actually it's so much easier if we do it vertically, but it's hard to write that way. So your lowest value is at 3, but it's not included. Your highest value is at 2, and it is included. And so when we write our range, again, we're going to do lowest to highest. And so lowest is -3, and highest is 2. And we're talking about all of the values that are y between them. And the fact that this wasn't included here, so it's going to be just a less than, and that it was included here, so it's going to be less than or equal to. And that's your range. Other than that, what happens, and it actually makes it so much easier, is if instead of this image, you actually have an image that goes on forever. So then when I ask you what is your lowest value, you're going to end up having to say negative infinity. And your highest value, you're going to end up just having to say infinity. And we want all of the x's between that. All right. The last one is points. So what happens sometimes when you're graphing is that you end up having just dots. And this might happen, for instance, when you have ticket prices, for instance. Okay, so let's say that you have tickets at a movie theater, and of course we're not going to movie theaters right now, but either way, there's a child price, right? Okay, so a child going into a theater has this price of $5. But then once that child reaches age, whatever, 10 or something, all of a sudden they start getting that adult rate. So now all of a sudden they are at the $15. Okay? And so then the problem is that, oh my gosh, what if they turn 65? They're on a fixed income. Oh, well, now we're going to throw in the $10 senior rate. And so then you go down here. So and actually, usually people have an end, but we're going to go ahead and give an arrow there. Okay, so the idea here is that the domain x's is going to be everything. Well, actually 0, because it stops, to infinity are your x's. Okay, but your range, now this is interesting, your range is only going to be a list of points. It's going to be 5, 10, and 15, and that's it. Because they don't actually charge you $7 if you're like halfway between 10 and 30 or something like that. So the range ends up being limited to just those intersection points. So lots of stuff happening here, but basically you're looking for the least amount and the highest amount, the lowest amount and the highest amount, and talking about if they're x's or y's. So we'll do some examples to kind of figure this out. So taking a look at our first set here, I'm not going to scroll down to the domain because then you'll see it. The domain, for instance, notice that this is going to go on forever in that left area. So the domain is going to continue on to the lowest point of negative infinity. The domain is also going to continue on to the highest value, which is infinity. And so when we write our inequality, if that's our lowest, and this is our highest, we want all of the x's between, and then we say that x's are less than infinity, but then they're also greater than negative infinity. See how that x is in the greater than part's being eaten by that Pac-Man there. Okay, so I'm not going to scroll down yet because I'm going to do the range. So when we talk about the range, we're trying to find the highest value, and again, it goes up to infinity. And then we're trying to find the lowest value, and it goes down to infinity. And so we're talking about all of the y's that are between infinity and negative infinity. And so if we want all the y's between negative infinity and infinity, just because this is vertical, it's hard to write, we would say that the lowest value is negative infinity, the highest is infinity, and we're looking for all of the y's that are between it. You will always be doing less than signs here. Okay, you will never do greater than. For some reason, people want to write it this way. But that is trying to say that y is greater than infinity, which is literally not possible because infinity is the most. So instead, you're always doing less than signs. Okay, sometimes it'll be less than or equal to, but it will never be greater than. All right. So taking a look down here, you'll notice that that's what we wrote for our domain and our range, but then, ooh, fancy symbol. Instead of writing negative infinity to infinity, which happens a lot, this is our shorthand. Alright, so basically all it is an R that's actually bolded, but because we can't bold with our handwriting really, I mean, I'm sure you'll try now, but the idea is that you end up just doing two lines right next to each other. Kind of like a dollar sign has those like lines in it. Okay, that's what you're doing. You're doing two vertical lines and then kind of throwing an R off of that. What does that mean? It means all real numbers are real, because there are actually complex and imaginary numbers, which we are not going to get to yet, okay? So this is just saying all numbers, and by the way, they're the real ones, so. Lot to take in. So, continuing on, we will put this to our next few images. So, alright, so I kind of went through and erased that, but clearly it's on video, so you can just go back. But first we're going to do the domain. Domain are x's, okay? And remember that we're always doing less than signs, okay? I can fill in an equal to if I need to later, but right now, less than's, okay? So, all I need to know is how far left it's going to go and how far right it's going to go. So looking at our equation, it's going left for negative infinity. It's going all the way to the left. It's also going right to infinity. So how far does it go left and right? It goes forever and forever. So remember that we also have our shorthand for that, so we can also say all real numbers. Now, we have to be very careful when we do that, because range starts with R, and so does this all real numbers thing, and so people start to confuse them and mesh them together. This R has nothing to do with the word range, okay? It instead has to do with the word real for all real numbers, okay? Then we have our range, and our range is going to be the y values, and again, less than symbols. And so now we just need to find the lowest value that's going to happen and the highest value. And so the lowest value, again imagining this going up and down, how far down is it going to go? It's going to go down forever, so negative infinity. How far up is it going to go? It is going to go on for infinity. So we are going to have negative infinity to infinity. And then of course we could also do all real numbers if we wanted to save some time. Okay. So we continue on. Now we're looking at this one. How far left is it going to go? It's going to go, even though it's slowly, on forever, and on forever left and right. So again, the lowest and the highest, or the left and the right. I like how I just put right and height together. Okay. And so the lowest number that it is on your x's, or actually it's easier if we think of it as left and right. The x's, again less than symbols, are going to go all the way to negative infinity and all the way to positive infinity. Then you have to switch. Now we're not talking about a left and right axis, we're talking about up and down. So now we're saying how far down does it go? And how far up does it go? Well, it's y's, and it's between a number. And so how far low does it go? Oh, it actually ends up stopping at 2. Does it include 2? Well, if we erase, yep, it's a solid circle, so it's going to stop at 2. And how far up does it go? Infinity. So now we get to put 2 down here, and an equal to, because it is equal to 2. And then how far up? Infinity. Apparently my pen has turned off. There we go. Alright, continuing on. These ones are kind of the same as our previous, but again, taking in how far left and how far right we go. Our x's are to the left, negative infinity, to the right, infinity. Or, of course, we could do our little symbol of all real numbers. It's just hard to do. There we go. And then for our y values, again, y values, we're going to end up talking about how low does it go, which is 0. Does it include 0? Well, yeah, it's a solid dot there, so definitely includes 0. And then how far up does it go? It goes to infinity. So you're kind of making this like viewing box, like how far or how much is included where this graph sits. Alright, then the next one, if you notice, well, is going to be the same. Even though it's shifted a little bit, it still goes to negative infinity and infinity, and still stops at 0 and goes to infinity. So filling it in, we've got 0 as our lowest point, and infinity as our highest point, and then our leftmost point is negative infinity, and our rightmost point is infinity. Alright, these ones get kind of fancy. Here we go. So, taking a look at this domain, how far left would we go and how far right do we go? Well, it turns out it's infinity, so I'm just going to put all real numbers, that little fancy R. But then our range, that gets tricky. So how far down does it go? To the number 4. How far up does it go? To the number 4. So because it's literally just at 4 for the range, we get to make one of those lists. So we get to, in parentheses, list the numbers that it exactly touches, which is just 4. And that's it. Technically what you'll see in an answer key would be Y and then a colon, indicating that that's for the Y values versus for the X. So if you feel like putting that in, sweet. Then the next one, this is where our domain is a little restricted, because again, how far left does it go? Just 7. How far right does it go? Oop, just 7. And so we're just making a list of 7 as our range, or sorry, our domain, which is your x's. The range, however, is the one that ends up going up to infinity and down to negative infinity. So we go back to that being all real numbers, or you can write negative infinity to infinity. So hopefully that helped you out with your assignment. So your assignment is going to be identifying domain and range, and if something is a function. All right.